AP Computer Science, practice test number 3, for response question number 4 out of 4. Just again, these problems were all from 2019's free response test last year, so very relevant. This is the only problem that has some stuff that won't be on this year's AP test, so there won't be 2D arrays, but there's other content in here and logic that is relevant. And 2D arrays really are just extension 1D arrays. I kind of like 2D array problems on free response. I feel like they're usually kind of more straightforward. You just have to figure out how to go through them. This one has some interesting stuff, but let's see. So it says the lightboard class models a two-dimensional display of lights where each light is either on or off as represented by a Boolean value. You will implement a constructor to initialize the display and a method to evaluate a light. So public class lightboard, the lights on board where true represents on, false represents off. So it's a private instance variable, 2D array of Boolean values called lights. So you're definitely going to be accessing that probably in everything we do. Constructor, which you're going to do, which takes a size num rows, num columns for the size of the 2D array. So you're going to have to create new. You have to initialize the instantiate and initialize the private instance variable that's only been declared so far. And it says that there's a 40% probability that a light is on. So generally with probability problems, we're going to use math.random. So that is fair game on this year's test. That's separate from 2D arrays, but it happens to just be incorporated in this problem. Also, there's a method, public Boolean evaluate light in row column, evaluates light in row, index row, and column index column, and returns the status as described in part B. So we don't really know exactly how we will determine that yet, but that's fine. Part A says write the constructor for the lightboard class, which initializes lights so that each light is set to on with a 40% probability. The notation lights RC represents the array element at row R, column C. Complete lightboard constructor constructs lightboard object having num rows, num columns, columns. Precondition num rows is greater than 0, num columns is greater than 0. Post condition, each light has a 40% probability of being set on. So in a constructor, any of the private instance variables need to be initialized, which is what we're going to do. But if it's an object, they have to be created. So lights equals new. Now, some of you guys put public Boolean in front of this, like as if you were declaring it. It's already been declared. Do not declare it again. You will lose points. It's a 2D array of Boolean values, and the dimensions, the number of rows is num rows, and the number of columns is num columns. And that's a point that you either gain or you don't gain. So that's a point. This is going to be out of 4 points, part A. So next we need to fill it. So we're going through a 2D array, so we have to do nested for loops, row major or column major order. But generally we do row major. So I'm going to say int row equals 0. Row is less than, now I could say num rows, or you could say lights.length, either one. And then row plus plus, and then we do another for loop, int column equals 0, column less than num calls column plus plus, or you could do lights bracket 0 dot length. Now, for each of these, we definitely need to check something. So we could do math.random, And we could just use the double value that math.random calculates and say, well, if it's less than 0.40, that would be less than 40. That would be a 40% probability, seeing as math.random can give you 0. So this is what's supposed to be the solution. If you said less than or equal to, you would get full credit on this problem based off their scoring guidelines. Some of you guys tried to went ahead and scaled this to 100. You did like a math.random times 100. You probably should do like 101 if you're then going to cast it afterwards and then say that it's less than 40. Because if you're going to cast it, it's going to truncate it. So if you do 101, then you can get 0 to 100. Now, you shouldn't add 1 afterwards because that would be 1 to 100, as if there's no 0% possibility, which is possible. But you could just use the double. So if that's true, then that means lights row column must be on. And the way we signify it being on is by setting it to true. Else, it must be off. So why don't we set it to off? Right? It's either on or off. So true or false. And then your for loop, and then your outer for loop, and then your whole method is done, and you get all the credit. So it's 4 points, 1 point for instantiating, initializing private instance variable. 1 point for accessing all elements of the 2D array without bounds errors. But accessing, it's not enough to just have the rows and columns. That means you have somewhere accessing it. So you got to go through all of them and you have to access it. Third point was computes the 40% probability. So something like this will give you this, will give you the 40% probability. That's another point. And then sets all variables in 2D array based off the computed probability. So now some of you guys just did true and did do the false, which actually works. Do you know why that works? Well, in general, when you first create anything with Boolean, by default, it's set to false. So all of these are actually false to begin with, and therefore just turning on the true ones to true and leaving the false ones false will work. But I just want to make sure you understand that. But you would get the credit for that also. So I thought that one was fine. The math.random part was really only 1 out of 4 points, but those points were, I don't know. I didn't think they were too confusing to get. The next part is, I think, doable, but it does take a little bit of focus to make sure you follow the rules. So it says, write the method evaluate light, which computes and returns the status of the light in a given row. So we got to return the status. The status is kind of weird and complicated. If the light is on, return false if the number of lights in the column is even, including the current light. Now, it doesn't say else return false, and some of you guys did that. That was wrong. It's just if this situation is this way, we're going to return false. Another situation is if the light is off, then we're going to return true if the number of lights in the column is divisible by 3. Now, divisible by 3 is going to be modulus 3 equals 0. Even is going to be modulus 2 equals 0. Right? And that's something we've talked about before in previous assignments and stuff. Otherwise, if the light's not on and this isn't perfect, and if the light's on, then we're going to just return the light status. So the people who said, if this return false, else returns true, well, then you're really just skipping this last option. That last option is just never going to happen. So These are very specific things we're looking for, and if they don't happen in the very end, we will then return light status. For example, they give you this game board, and this might be good to look at. They say evaluate light at 0, 3. So the first one is row, then column. So it's true, and then we're looking at all the values in the column. If the light is on and the number of lights in the column is even, 1, 2, 3, 4, then we return false. So if the thing we're looking for happens, we return false. 6, 0 would be here. If it's false, lights turned off, and the number of lights turned on in the column is divisible by 3, which they are, then you return true. So we're going to have to count the number of turned on lights in that column either way. So we should probably create something to keep track of those and count them no matter what. We should probably just go ahead and whatever column we're in, count them all. Now, this is one of the big mistakes people made, was that when you were given a row column, you counted everything in the row. No, you're supposed to do the column, which means the column stays the same. It's the rows that change. Okay, if you're counting everything in a column stays 3, and you go through all the rows, not the columns. So, this is worth 5 points. And so it would be helpful to have something to count the lights that are on. That's what we're trying to really analyze after we decide if the current light is on or off. So we could just jump right into that. Now, we don't need nested for loops because we're not going through the columns. We're going through the rows of a column. And some of you guys decide to go through the columns of a row. That's not the right thing. That's not what they said. They said to go through a column, not go through a row. So that would cause you to lose points if you're doing columns here. Now, you might get away with just losing 1 point for kind of a big error. So we need to count the lights that are on. So we're going to check if the row, and then column just stays column, right? That's the thing that stays column. And we could say equal equals true, or we could just say that because it is Boolean. So if it's on, it'll be true. And then we could increment our counter. And you get 1 point for accessing any light. You get 1 point for going through all of the lights in a column. And you get 1 point for incrementing the counter. So right there's 3 points. And you haven't even gotten into all the weird different scenarios. We just know that we're looking at a column and we're going to know how many lights are on, and then we're going to make some decisions. So we do all that. Then we say if lights row column. So now we're going to the specific row and column. If it's on, and we could do, instead of this, we could do like an and thing. I can show that in a second. But lights on modulus 2 equals 0, then we're actually supposed to return false. Okay, so we're never going to return true from this situation. But you could have done and lights on like this instead of that, just to make it a little more compact. Now, you could say else after this. Now, depending on how you did it, if you did it that way, then that means the light is off. And then you can just check. You could just check for the other situation. Lights on modulus 3 equals 0. Then you return true. But if you did it like this, you couldn't do this, because If this was false, it could have meant that both of these things were false or one was false. So just because this whole thing is false doesn't mean that the light is off. The light might have been on. So that's where this might be a little better. Otherwise, you're going to have to do them as separate. You're not going to want, if you do this, you're not going to do the else. You're going to do a separate if. And then after this, you could either, you know, you could say else and then just return it, or you could, because it's in a method, you could just say return lights row column. So if these don't get returned, then this last statement is just going to happen for sure, right? Now, the 5 points, a lot of them are gained right at the beginning, accessing the lights, going through all the lights in a column, incrementing your lights on, doing division. Both of these, you get a point for, they say, performs an even calculation and a multiple 3 calculation. So this is an even calculation. This is multiple 3 calculation. And then the last point is returns true or false according to all 3 rules. So the last point is you did it correctly. Your code will return the right thing. So that was a little, little complicated, lots of different weird overlapping kind of rules and stuff. But like I said, most of the 3 points right at the beginning were kind of easy to get. Like if you just kind of understood sort of the basic idea that we're focusing on a spot and we're focusing on that column. We want to know how many lights are on so that we can make some evaluation of whether it's even or divisible by 3, and then with combined a bunch of other things. So, but you shouldn't have 2D arrays on this year's test. But that would be the only thing I would say out of this whole free response test that you wouldn't see. And I personally don't mind 2D arrays. I kind of like them in comparison to the other problems. I feel like I can just think through them a lot easier than some of the other problems. Like I would pick a 2D array over like a complicated string problem or something like that. But anyways, there you go.